So for question number 4, where the asking us to find us the joint density, no, not joint density, they have given us joint density for two random variables, x and y, which is defined as such. So this is basically a PDF of the joint density, uh, 2 over 3x plus 4 over 3y, and then both the values are going from 0 to 1. And we also know that f of the joint density is 0 for all other x and y. So now we have to find the probability when x is less than y. So the way we find probability is just by integrating, and because it's a joint density, we need to integrate it twice with some uh, like our PDF function, which is joint density basically, and our two bounds. So they said to find where is x gonna be less than y. So our x basically goes from 0 to y, because the lowest bound from 0 is of x is 0, and the highest is y, because they're asking us where is x less than y, but the bounds for y remain the same. So it's just going to go from 0 to 1. Then we just plug in the values, which is 2 over 3x plus 4 over 3y dx dy. We take out 2 over 3 x plus 2y dx dy. Now we just integrate in the terms of x, like we take y as a constant. So the way we do that is we still have this integration bound, but we just solve this part of the integration, uh, which turns out to be this. And we plug in the values of 0 to y. And we get we solve in terms of y, and we get 5 over y. For 1.5, now we're expected, I want to calculate the expected value of x given y. So the way to do expected value is to find out this term, like the outcome times the PDF function of x given y dx. This dx bound is basically because x goes from 0 to 1. Then we do like this thing, basically f of xy over f of y. This is by the base rule, if you guys remember. Not base rule, conditional probability. The probability of A given B is probability of A intersection B, and it's basically this, but in terms of PDF. The x remains the same. So the main thing we need to calculate is the, not this one, this is already given in the question, but this term, f y, f of y. So the way to do that is through calculating marginal density, which we get if we integrate our joint density over the values of x. So if we add on all the values of x in the joint density, we should get the marginal density for y. This is how it works for normal discrete probability and how it works for the continuous case as well. And just the difference is we are integrating instead of summing. We basically get 4 over 3 y plus 1 over 3. Then we plug these values into expected value formula. Um, we continue this video and we get to over 3 plus 2 pi over over 3x over 3y plus 7. This is again our joint density. But yeah, if you basically do the integration, you should get 6y over 2. Lastly, we have, let's see, sorry, this was at 5. Let's see, expected value of x times y. This is pretty intuitive. It's just doing everything right. So how normal expectation is 1 integration x of 5 x dx. For double integration, you just do everything twice. So then the bounds typically go from negative infinity to positive infinity. But here we know that our x and y are bounded by 0 to 1. So we go from 0 to 1. Then we just plug in every value. What's the value of x? Maybe it's we take out 2 over 3 there. Uh, yes, I took out 2 over 3 here. We get the first integrated term of x, then integrated of y. I should be getting what it was.